So that's why it is different. So big data technology is totally, it's not working under the client server technology. Okay, they are taking the SQL server. It's a client and server concept. Here there is no client and server. Okay, here master and slave concept. It's distributed computing concept. Okay, so whenever you are sending a request, the server will respond. For example, create table name, and then if you put employee table, then it will be server will respond back. Okay, query is executed. Right? Query is executing client or server. Query is executing a server. Then it is responding back to the client. Your table has been created. Insert into table column. 2 rows are reflected. Something it will come. So it is reflecting in the server. The server is responding by okay. Query is inserted. That is the client server concept. So here we are going to do in the master and slave concept. So every computer will have definitive of master. That's similar to our server. We will call it, but in big data terms, we have to specify the master. And then all the client machines are slave machines. So if you are giving a insert into table name or create table result, previously server is working. Now the server will not work. Client will work. Client will execute and it will respond back to the server. Okay, I completed my job. So that's the difference between a normal technology of the older technology like 20 years back, client server technology, and then the latest technology of distributed computing, the big data. So next thing is 3 varieties of volume. We'll just open this slide for a minute. Let me check with my slide. So how many people know big data already? The meeting and here 1, 2, 3, 4. So new people know big data. One session only attended. Okay, you one session attended. You too. Yeah, one session attended. Okay. So let's just quickly summarize for 10 minutes about the history of the big data. Guys, we are not going to discuss in depth of big data today, but at least high level. We'll just recap it quickly. Dinesh, we'll extend for now. Go straight to it, go straight to it. So I'm trying to share the slide. So what is big data all about? Big data is the collections of data set. It is large and complex. Okay, you cannot able to process those kind of data in the normal Oracle or SQL server. It is very technical. You can able to process. It will take months, it will take years to process your terabytes or petabytes of data. If you want to process the Oracle or SQL server, it will take months and years. Okay. So big data is a collection of data set. It is large and complex. That is very difficult to process the on-hand management tools. Okay. So next few things we have to understand this slide. Okay. So big data is all about volume, variety, and then velocity, right? So what is this 3V concept? Guys, whoever is in the webinar, please talk.
Yeah, go ahead.
Can you just somebody describe us what is the volume, what is the variety, what is the velocity?
Volume is the amount of data that we use to process, and the variety is the different types of data like structure, unstructured, and semi-structured. And velocity is the time, the amount which is equal to the timing we use to process those data. So these are three V's.
Okay, that's good. So volume tells of what is the volume you are expected, the global level of data. For example, Facebook, Google, Twitter, YouTube, Flipkart. Any website you take, how much of the volume of transactions every day is happening? Huge records, right? So those kind of huge records and come as the terabytes of data. It cannot be processed in the normal table. So that volume here, we are discussing about the volume size of this size. We are aware of till terabytes, right? After terabytes, we have petabytes. Then exabyte. After exabyte is zettabyte. Then here exabyte. After exabyte, what is pronatobyte. After pronatobyte, gigabyte. Gigabyte. So that is the huge. Well, many people may not aware. It is not even come to the industry. This kind of high level of volume. Even we are not even reached the zettabyte or exabyte level. But even the exabyte, there is a pronatobyte is there. Byte is there. So this kind of bytes are available. Maybe it will come after 2045, 2030. During that stage, it will come. Okay, but we are going to process that much of volume. So when you are growing like another 10 years of time or 10 years experience, you have to work on that kind of level of volume. Okay, so be ready for your technology is coming very fast rapidly. Ensure that you are traveling towards. So we are at terabytes, right? After terabytes, how much of volume can able to process? Structure in the terabyte itself, there is a three types. SQL Server is only structured data, but here you can do any kind of data type: structure, semi-structure, unstructured, all the data types you can able to process. So these are the three main concepts: volume, velocity, and variety. Okay. So next thing is 4V concept. The 4V is okay. We have large volume, we have large data. Data terms is there. Data accumulated of many satellite feed or Google search, internet, world, extra databases. What is the use of the data? What you are going to do with the data? So that comes the value creation. How we are going to operate the business based on what is the value we are going to achieve. Okay? So that's where you are going to specify volume, variety, velocity, and then value. Okay. So where and all these data are creating? In 2020, there are 40 zettabytes of volume going to be available. 6 billion people are having mobile phones, right? But the whole population is 7 billion. But again, I think now it must be 7 billion to 7 billion. All the people have mobile. 100 terabytes every day. Most of the companies are generating the data. US-based companies, they are generating. The other things, New York Stock Exchange, they capture 1 terabyte trade information during each trading session. So every day 1 terabyte of trading information. Likewise, globally, how many trade centers are there? 100, 200, 300 trade centers may be there, right? So each day they are producing terabytes information. But that's not mean by terabyte of information, but volume, how we are going to process. It is 1 day is 1 terabyte. But if you want to check that whether I can go for the share or not to make the decision making, machine learning or decision analytical, predictive analytical, you have to process last 10 years of data, 5 years data. Last 5 years of data, how many terabytes will come? That's where you have to accumulate. It's not like 1 day is 1 terabyte. 1 month is 30 terabytes. 1 year is 360 terabytes. Okay, last 5 years, you have to add that it comes around 2 terabytes of data. You have to process within a minutes of time. You have to decision making things will happen. So that's comes in the the velocity. So velocity is how fast we are processing the data. Variety. Variety in terms of, for example, here in the internet world, there are different type of formats of. Some people use the XML format, some people use the text format, video format, audio format. Even the video, they have multiple video types. Some people will say MP4, some people will have some other format, right? So all the video format need to be read, right? So those things also can be processed in the through big data feed. Okay. So we have important, very much important concept is the MAPREDUCE. Hadoop MAPREDUCE. That's very important concept. That will understand a little bit. Okay, there is another technique called Hadoop framework. Right? You must be aware of the training people who are there. What is the Hadoop? Is it a big data software or Hadoop is software? What is big data? Big data, what is the software version number? I mean, Hadoop, what is the software version number? Let me put in. Hadoop is 2.8. What is the big data software version number? It's a concept. Okay, big data is not software. Big data is a field of science. Okay, big data is a big field of data analytical science. Under the data science, you have big data field. Under the data science, you have machine learning, you have big data, you have other hundreds of fields of subjects coming under the data science. Under the big data, you have thousands of softwares are available. Similarly, Hadoop is one of the small software, which is most popular widely used on the big data space. Apache Hadoop is one of the open source framework which has been available in the apache.org. You can just download over there. The open source software, you can just download and use this. Okay, Apache Hadoop which has been found in the 2003. Why they have found this Apache Hadoop? Anybody deep brief? Why they have found the Apache Hadoop? What is the problem they faced in the data science field? They have found this. Why they found the Hadoop? Hadoop is the one of the software, right? What is the purpose they have to found this? See, Google is one of the company they found this. Okay, so Google, what is the Google company? Whatever you want to do, you will search the Google search, right? How many times you are searching per day? Google search. 100 times? More than 100 times. So similarly, just count that how many people in Chennai they are searching Google search. Crores and crores of people, they will do the crores and crores of requests to come, right? Similarly, check India. Similarly, check about worldwide. How many people, 1 second they are putting the Google search. So they keep on hitting the server and then responding back to the client that found this result, right? So Google is unable to manage this large amount of requests and response. Okay, during 2000, they have started 95 and around 4 years they can able to sustain. After that, they are unable to handle the large volumes of data which has been unable to process. They can able to show the result. Last initially 95 and 96 and see, they can able to say 1 lakh result is found. Okay, now only they are putting the 100 crores result is found. Initial period they have found only 1 crore, 1 lakh records URL is found, right? Even that they are unable to process because of large volume of data. So they found that there is a 2 people they found in the white paper. They published the white paper. It's called Google File System. Okay, the Google File System they have put the how to store and retrieve the files in a faster way. So the normal hard disk will come a sectors, right? 0s and 1s you need to read. Instead of that hard disk, you have to have a layers, logic layer where you can able to block 64 extra block into read and write. So that's a Google file system concept that they are published in the year of 2003. Okay. So after that, they have discussed internally with the Google research people. Okay, you have given a solution how to store and retrieve the files, 64 in the block size. How to process very fast. I put the 64 MB instead of 3 KB file system of hard drive. I put into 64 MB of block size. How to process very large size means they published another concept called in 2004. After 1 year research, they found the MAPREDUCE concept. So MAPREDUCE is one of the very important concept in the big data field, in Hadoop field. Without MAPREDUCE, it cannot be run any program. Okay. So map and reduce is the key comma value pair concept. Any value, if you are processing large data, each block size, the blue color box is 64 MB of block. That's going to be processed to key comma value pair concept. Each block is a value. It will have one unique key because it may not know if you are giving 1 terabyte of data. It is sliced into 64 MB of block. You need to know which 64 MB block is processing. For that, it need to have identity, right? For example, here there are 10 people are there. Each people have unique name. So if they call by somebody name, they can able to identify. Similar way, there are 64 MB of block size will be there. Based on that, it need to identify which block is processing, which block is not processing. Those identifications that comes into the key. So that has value in the one block, 64 MB block. That will map into key and value pair concept. Internally, this MapReduce is an engine or a framework. We have .NET framework, right? We have Java framework, right? Similar way, Hadoop is as a framework, as a MapReduce framework. Okay, MapReduce is an engine. They'll call it as a MapReduce as a framework. Okay, so here they will do the sorting, shuffling, bubbling, all those things they will do internally, and it will process your data. So it is slicing into 64 or 128 numbers of block size. So these two concepts is very important. HDFS and MapReduce. There are other tools are available. Tick, Hive, HBase, Flume, Uzi, Scoop. These tools are also available, which is also additional tools for the big data processing, data processing. Each tool has unique version. Okay. It does not mean that Hadoop can able to process all the way, but the thing is a different language. Hive is having different language. HBase is a database. Hive is also database oriented. Flume is the one of the workflow oriented. Uzi is the workflow. Flume is the one of the log file management tool. Scoop is the one of the import export of your SQL Server data into data processing. So similar way it will be going to process your data. Okay. This is the guy who found the Hadoop. Right. This is written the software in the Java. The Docker team. Okay. So this is a Hadoop framework. We have the HDFS, MapReduce, Tick, Hive, Scoop, HBase, Flume, and then Uzi. So these are the list of tools which is most popular, widely used across the industry. So next 10 years, this kind of tools only many people will use in the IT industry. Okay. So understand this. There are two concepts there. One is the name node, job tracker, and task tracker, and data node. Name node is one of the naming. So I told you, right, key comma value. For the key comma value, the key generator name will be there, right? For each data block, 64 data block, that need to generate one name. So that will be created by the name node. That's the server. Server will create a name for each and every data block to send to the multiple computer. 100 computer if we connect, 100 computer power will get. If you connect 10 computer, you will get a 10 computer processing power. So if 10 computers need to process, somebody need to put the name for that data block. Okay, I'm giving 0001 for the your data block. You go and process your data in the computer 2. 0003, you go and work in the computer 4. So that is the one thing activity will perform by the server. It will not process your data, rather it will create a name for your data block and send to the computer, distributed computer. So Master is one of the server. Consider this a master is a server. Based on it, it will work. So then the job tracker, it will maintain which job is performing in which computer. If you are connecting 10 computers, which particular data block is processing on which computer, that will be maintained by the job tracker. And there is one more metadata is there, H master and then metadata. So that will maintain the master of registry. Okay. If you are having 1 terabytes of data, it is processing in 10 different computers. Where it needs to be processing, what it is processing, that needs to be maintained in the registry, right? So that has been maintained by the metadata in the master. That's called H master. There is one more library today. It's called metadata. So there only it will store all your data. So then we have the data node. That's called slave nodes. Okay, slave machine. Each slave machine will have one data node, right? Multiple data nodes also will be there. Slave machine is the one PC, and so you have one computer. Similar way in server concept, you have 16 computers called one rack. Okay, the server concept you can say the rack concept. So you have in the slave node, you have a data node, and then you have a task tracker. What are the tasks that will be performed on this data node? That will be maintained by the task tracker, and job tracker will be maintained by the which job need to be performed by which computer. So that is why it will work. Okay. So then we have this is the structure of your architecture. Any questions so far? Anyone has any question? Are you able to follow this Hadoop architecture?
The main advantage is can make it a commodity.
Yes. Yes, normal.
So how can we judge that? Either name node has to be given more RAM space or how
Okay, normally it is advisable for master node not use the commodity hardware, but it's not officially informed. But it is advisable to have a master node with server based server, high level of computer, and then all the pieces can be any kind of computer. It can be Pentium 4, Pentium 3, i3, i5, i7, any kind of data is the same for all the concepts. They're having more RAM, it will process very fast. But it will also run. If we have 4 GB RAM, it will also process. Does not mean that. But if you're using cloud raw software and all, it requires 12 GB RAM. If you're using Archon work, you need a 8 GB RAM. Then only it will process effectively. If you're using normal Hadoop open source, you will get 4 GB RAM is enough. So it depends upon the how your local market can procure the computer, and then you can set up your own startup company or whatever the software you want to develop. You can start it. It does not mean that you want to invest a huge investment of your computer, servers, all these things. If you are having a server, software, right, you will require at least 3 lakh rupees of one server. Okay, but in the normal PC, you can get it in the 40,000, 50,000 rupees, you will get the computer. So you can buy the 10 computers, 4 lakh itself, instead of buying one server. You can buy it in our 10 different computers and able to process terabytes of information in a very fast way using the Hadoop tool. Okay? That's very important concept. Commodity computing. Okay. So other things. So we have a SQL server, scripting, query. Okay. What is HDFS? Can anybody tell in the webinar? Go to meeting. What is HDFS? We have discussed day and day. Whole day we are discussing about the HDFS. What is that? Hadoop distributed file system. Okay. That is very, very important concept in the big data field. Without that, we cannot able to store the data in any way. All the data need to store in the safest layer only. Okay, then we have the distributed processing of MAPREDUCE. These two layers is called version 1. Okay, I have one slide for that. That is the slide. Yeah. Okay, so here we check that HDFS and the MAPREDUCE for Hadoop 1.0. Then version 2.0 they introduced yarn technique. Yarn is the yet another resource navigator. No, it's wrong. Negotiator. Some people it is that. That's right. It was repeated. So yet another resource negotiator. It will negotiate to the computer. I need a 2 GB RAM for processing my data packet. Give me 2 GB RAM. It will maintain that. So the yet another resource negotiator will go to each computer. It will be available on each computer. Master will inform that to the slave. I want 2 terabytes data is coming and transferring to computer 2 to take care of it. So yarn will take care of the okay 2 terabytes of data is coming. I need to make sure that 2 GB RAM I need to make it free. I need to make sure that computer is working. So I need to free up the space also. I need to allocate the space also. So that resource management stuff the yarn need to take care. But in 1.0 there is no yarn. How they manage? Anybody aware how they manage? How to allocate the resource and all? In 1.0 also yarn was there, but it is a separate component. It's not a separate component, but the small library files is instantly managing the resources. But in version 2.0 they have made it a separate component that need to manage all the resource management components in one single component that they have made at the yarn. Okay, so that's where it was started. Okay, so this is how the architecture of HDFS. You process your name node that will have metadata. That metadata will maintain the name and all the history. So it will maintain a 3 replication. Okay, always it will maintain a 3 copies of your data packet. Okay, it will maintain a 3 copies of your data block. 164 MB block size is there. Same block will be processed to computer 2 and computer 3. It will keep a copy. If computer 1 is failure, okay, that some network failure is happening, some process failure is happening, it does not stop your data because you are processing huge data, right? If you are copying from one hard disk to another hard disk, in between power shutdown, what will happen? Again, you need to recopy entire stuff, right? But you can, if you are processing 1 terabyte, 10 terabytes, 9 terabytes data you process, 1 terabyte is a computer is failure. Again, you have to kickstart from the beginning. No. Till any failure is happen on the data node, it will process from the where it stopped, it will move to the next computer where the nearest next data block is available. From there, it will process the data packet. Okay, so that's called data node. So that's where we are understanding about Hadoop. So these are your data nodes which get stored. Block 1, block 2. Each block will be stored in a 3 replication. For example, block 001 stored in the computer 1. Also it is available in the computer 3 and then computer 5. Okay. So similar way this name who is giving? Block 001. Master node. Master node will be the name for the data packet. So it will maintain the metadata. By the way, it will process the data packet. Clear on this? Any questions so far? Okay, so let me call to the trainer. Just give me a moment.